Okay, so today we continue on with lesson 5.5, part 3, the last and final part of lesson 5.5. So with the problem of the day, I want you to take a look at the two problems, A and B. So far we have learned long division and synthetic division in this lesson. Which method or methods can I use for the following problems? Explain your reasoning. So I want you to actually take some time, not actually solve them, but for letter A, say, can you use long and or synthetic? And the same with B. We'll talk about it in class tomorrow. So now where we're continuing on with our lesson is we now say factor completely. If you remember in the previous part of the lesson, I asked you to do synthetic division. Well, now we're building upon that, and we're still going to do synthetic division, but we're going to continue factoring from that point. All right. So where I start is I make my little synthetic division box. If this is x minus 3, we set it equal to 0. My x will now be positive 3. And I take all the coefficients, and we go third power, second power, or first, constant. I don't need any zero placeholders. So let's put those numbers in here, like so. And do synthetic substitution. We bring down the 2. 3 times 2 is 6. Goes here. Negative 11 plus 6 is negative 5. 3 times negative 5 is negative 15. 3 minus 15 is negative 12. And we get negative 36. And what you notice here is my remainder is a 0. And that's actually very, very important. For today's lesson, your remainder has to be a 0 because we ask to factor completely. So you can't factor completely if there's a remainder. So if you get a remainder, you shouldn't have one, go back and fix your work. All right, so I think I'm going to type from here, since it's a little bit easier for me. Now, just to revamp, how did I get that 3 in front? What did I have? I had x minus 3 equals 0, if you remember correctly. I want to talk about this for a second. We add 3 to both sides, that's how I got the 3. That went here, right? Well, now we want to factor completely. Do you see how we had x minus 3? We actually have to include that one as well, because we are factoring all the way. So your original x minus 3 from here and from here has to be written. Now let's deal with our coefficients here. If I have an x to the third power, I step down 1, so it'll be x squared. So I have what? 2x squared minus 5x minus 12. So the x minus 3, now I want to include, goes here. Here's all my coefficients using synthetic division. Now, here's the deal with this one. It says factor completely. Does everyone see that? So now we're taking a combination of 5.4 that we've done before, and now you see we could actually split this one up, or it's going to be our guess and check factoring. So let's take a look here. So x minus 3 is good. I have a 2x squared. That means I need to put a 2x in one parenthesis, 1x in the other. Signs are different. And I have to guess and check where each of my numbers go. So I'm going to pause the video and think about that for a second. So hopefully you had time to think. Signs are different, so it matters if the plus is here, the minus is here. We have factors of 12, which is 1 times 12, 2 times 6, and 3 times 4. What you'll find out that works, I'm going to delete some of the spaces here, it's 2x plus 3 and x minus 4. Now, how do I know? Let's talk about for a second. Check OI. What's the outer? 2x times negative 4. I'll type it over here. Is negative 8x. This is the check I. Then I come back around. 3 times x is positive 3x, which equals negative 5x. And if I look, here's negative 5x, so that checks out. You'd ask yourself, can you factor further? If you take a look, no, we're down to x's now, so you actually can't. If you had an x squared or x to the fourth or something else, you might be able to factor further. But actually, this is my final answer. So you're doing synthetic again, synthetic division, but the extra step is to continue on with factoring like 5.4. Once again, factoring doesn't go away. It comes back another part of the lesson. All right, well, we have one last example. Once again, the notes are short. What if we want to find the zeros? So what if we had that equals 0 here? How would we solve that one? And this is what it might look like as well. It says a polynomial f and 1, 0 of f are given. So you could read that a little bit better. There we go. Sometimes when it comes up, it's hard to see. Of f are given. Find the other zeros of f. So instead of this time them saying it's x minus 3, they actually already give me the number 3. So I don't have to switch the signs on that. I just write 3. And I do my little box here. Write all your coefficients. So you have 1, negative 2, negative 23, 60. We're going to do synthetic substitution, division. Bring the 1 down. 3 times 1 is 3. Now you have 2 plus 3 is 1. 3 times 1 is 3. Negative 20. And once again, you know you have done synthetic right if get a 0 remainder. All of these in this part of the lesson will be a 0 remainder. If not, you have to go back and see what you did wrong. Now, remember here, we're going to write it as in factoring terms. If I told you x equals 3, it's pretty much what I told you here. Same thing, it's the same thing here. If I want to move it back over, and I bring the 3 over to the left, it's what? X minus 3 equals 0. All right. So how that applies, let's type it out like before. So it's x minus 3. It's always the opposite sign. This was an x cubed, so this has to be x squared. So 1x squared or x squared plus x minus 20. And now we want to find the other zeros. So here's what's extra. Now we're going to put it equal to 0 as opposed to, if you go to the previous slide, just factor. There's no equals 0 here. We have to factor again. So bring down the x minus 3. Here we put an x in each parenthesis. Think about actually breaking this apart first without me saying anything. We want to pause the video. So you get x plus 5 times x minus 4. 5 times 4 is 20. 5 minus 4 is positive 1. And I'm going to set each equal to 0. And solve algebraically. And we'll just go with the final answer. You get x equals 3. X equals negative 5. And 4. And now this is my answer. Now granted, 3 was already there. I like to still write it and like show all the factoring to it. But here's your 3 answers. You get 3. My other 2 zeros are what? Negative 5 and 4. All right, that's it for today's lesson. Homework, I want you to do problem of the day. And then in the second problem, complete the following problems from assignment 11, numbers 1 and 7. And we will go over these tomorrow.